This lesson's on the sine law, but taking it further, looking at examples with two triangles and then some applications. So our very first example is going to involve two triangles. I'm going to draw it out here, and you should do the same. Pause while you're doing it, and then we'll continue. So here's the two triangles in example 1. So you've got the first triangle here, and a second triangle given that's 90 degrees, as shown. From B all the way to C is 100, and you've got some given angles. And then the question says, find side X. Okay, first thing we're going to notice is, where is X? Well, X is found in this triangle here, and that one seems to have the most information. It's also part of this triangle, but really there's only the 20-degree angle in that triangle. So let's start by seeing if we can do something with this triangle. And the first thing that comes to mind is this is a 90-degree triangle. So you're thinking SOHCAHTOA, your primary trig ratios, or maybe Pythagorean theorem. Now, if you were going to use Pythagorean theorem, you would need at least two of these sides known, so you can't use that. To try and use SOHCAHTOA, unfortunately, with only side X, being considered, he has no other sides to work with. He only has angles. And for SOHCAHTOA to work, you would need, if you want to find this side, you need an angle and another side. Okay, and we don't have that here. So trying to find a way with this triangle here, you're not. There's not enough information given. So far I've mentioned that there's this triangle and this triangle. There's actually a third triangle, the overall triangle. And if we take a look at the overall triangle, I'm actually going to sort of draw it in here as a orange color. We can work with this triangle now. Okay? And I know we want to find side X, and that's not part of the orange triangle. But what we can do is see side Y here is part of the orange triangle. And if we could maybe get side Y, once we have that known, we would have side Y, the angle of 20 degrees, and we'd probably be able to use some SOHCAHTOA to go find X. So that's sort of my strategy right now. If I could find side Y, I'll do that. And then I'll be able to use this reference angle here of 20 with some SOHCAHTOA using Y and X, and I'll be able to find X. So step 1 is to find Y. Step 2 is to find X. For step 1 to find Y, look at that orange triangle, and we're actually going to work out a sine law on it. Okay? And here's how. I want to find Y, and I'm going to use the sine law. So Y is this side, and who's his angle? Well, you have to go opposite Y, and you get to 60. So Y over sine 60, and I'm hoping there's a ratio in the orange triangle that's fully known. So we just did sort of this angle and that side pair. Let's see if angle B, well, he goes nowhere because there's no angle known here and there's no side known over here. So the only other option is angle A with his opposite side. And we do know angle A. It's actually the sum of those two. Angle A is 50 degrees. And we actually know little side A, again looking at the orange triangle, it would be 100. So we can go with that. So 100 would go up here, and it's the sine of 50 degrees. And we can solve this by cross multiplying, and we get the following. So Y equals 100 times sine 60, all divided by sine 50. You'll need your calculator. Okay, so 100 times sine 60 divided by sine 50 is 113, I'll say 0.1. Okay. And we finally have side y known. And we can write that in now. Okay, so we've got some more information. And as I said earlier, once we found y, we would then be able to use this smaller triangle here. So I'll just draw it in green. Okay, and in that green triangle, it's also a 90-degree triangle. Has to be, because this is a straight line. That 90 is known, and the missing piece would be 90. So that green triangle now being 90 degrees, we can use SOHCAHTOA. As soon as you have a 90-degree triangle, you're again allowed to use SOHCAHTOA, or you could even use Pythagorean theorem. So to find side x, let's check Pythagorean theorem. I know one side, unfortunately I don't know the other, so we can't use Pythagorean theorem. What about SOHCAHTOA? Okay, well the angle I'm going to want to use is 20, and that angle of 20 degrees, his opposite, well, I actually don't know it, his hypotenuse is known, 113.1, and x is the adjacent. Okay, so let's write in step 2 here, SOHCAHTOA out. And let's go through this. So I know I need to find side x, and he's adjacent to 20 degrees. So look for an A. And now the other piece I want to use is the known value of 113.1, which is the hypotenuse to that green triangle. So look for the hypotenuse. And you realize that you need to do the cosine. Okay, so here it is. The cosine, 20 degrees, is the adjacent side divided by the hypotenuse. The adjacent side is x. Hypotenuse is 113.1. Okay, I can cross multiply this over there, and you would get the following: 113.1 cos, and I'll just move the sheet up here, 20 degrees, and that goes in your calculator. So let's see what that gives. 113.1 times cos 20, and you end up getting 106.3. And that is your final answer. You were asked to find x. There's no units, so you've solved the question. So example 2 is one for you to try. It's similar to example 1. Have a look at it. And I'm giving you some hints here. The strategy is, first you'll find y, you'll use sine law. And then second step, you'll find x with SOHCAHTOA. Now pause the video here, give it a shot. Did you get it? Let me give you a few more hints. You'll use sine law on this blue triangle to come up with y. And once you've done that, you'll use SOHCAHTOA on this triangle here, the green one. Okay, and as for answers, you should get y's value here, 339.2, and when you work out x, x is going to equal 318.7. Now we're going to look at some applications with sine law. So take a minute to read example 1, and I'll show you how we draw a diagram for this and start using our trigonometry techniques, which obviously includes sine law, but keep in mind there's SOHCAHTOA, Pythagorean theorem, our knowledge of angles. So pause the video, read it, and come back. Alright, so hopefully you have a great idea of how the question presents the info, and there's two houses here, Tom's and the one across the street. The key thing with doing these is you really need to draw a good diagram, and make sure you put variables on the diagram that are appropriate. You'll then show all your calculations and end with a concluding statement. So let's start with a good diagram of this, and we're going to draw out Tom's house. So I'll do that now, and give me a sec. Okay, so there's Tom's house and his bedroom window, and I've got the ground. And now I'm going to draw the house that is across the street. Okay, so here you can see Tom's house, and I've added him in the window, and then the house across the street. And let's start adding the information. So Tom looks out of his bedroom window and looks across the street. So he looks across the street. The angle of depression of the front door of the house across the street is 10 degrees. Well, here's the front door, and it's the angle of depression of the front door, and we'll go to the bottom of it here. Okay, first off, angle of depression. So that means you've got some line of sight, and you look down. So if he was to look straight across Tom, he would see the house. But it says he looks at an angle of depression of 10 degrees to get to the bottom of that door. So he's actually looking down there, and he's depressed down 10 degrees. Alright? Then the angle of elevation of the top of the house is 5 degrees. So again, there's his line of sight, and he looks up at the top of the house, and he sees the roof, and that's 5 degrees. And an angle of elevation is where you would look up. Okay, a while ago for depression we look down. When you're down, you're depressed, and elevating is to go up like an elevator goes up. And the elevation angle here is 5 degrees. Okay. The other piece of information, it's 75 meters between Tom's house and the house that is across the street. So from here to here, we know that that's 75 meters. Part A now asks to find the height of the house across the street. Okay, so that would be from here all the way up to its peak. And unfortunately, this question has a bit of a shortcoming. We only know how far here to here is, and that's 75 meters. Okay, so if we want to use the information we have here, as far as angles of depression, angles of elevation, with the triangles we're going to create, we're only going to be able to find the height from here up to here. So this height. We'll just acknowledge that. It's just the way this question was set up with Tom. We'll be able to get this height, okay? And I'm going to call that height X. And it's this orange color. So we are going to be missing a little bit from here. And obviously there are other ways for Tom to look to make this happen, or the design of the house. But we're just going to illustrate this with a bit of a sort of accepting that there's a bit of shortcoming. And we're going to find this height X, which is approximately the house's height. Next, in a question like this, you're really going to want to put some information into your diagram, thanks to the angle of depression, and thanks to the fact that we have 90-degree triangles present. Okay, so first, this angle of depression, it's 10 degrees, and we learned before from angles of depression that there's like a Z here, and the Z rule says inside here and inside here, those angles are the same. So this angle is also 10 degrees, And that's by Z rule. Okay? And the way this is set up, this is a 90-degree angle with the ground. So all of this is 90, from here to here, which means what's missing here is 80 degrees. Okay, so we want to find side X. And side X is involved in a triangle. So I'll show you. It's involved in this triangle here. From there to there to there. Okay, let's draw it out. So from here to here to here. So side X, how could we relate that? Well, we've got the sine law, because this triangle here is definitely going to require sine law. There's no 90-degree angles in it. In fact, this bluish triangle has 80, 15, and we could work this one out. And also, we actually know we can actually use another side of this triangle, but it's going to require some work. Okay, with only having this angle known and this angle known, and we want to find side X, we're going to need another side. So first off, let's notice this. This length here is 75, which means this length here is also 75. Okay, and if we look at that 75 length, another thing we want to do is we're going to say we're going to add another triangle. This triangle here. And the reason we're going to do that is if we have this length is 75 and this 5-degree angle, we can go figure out this side here, which I'm going to call y. If we take stock of why we would do that, we're trying to find x. Across from x, we know his angle. If we could find y, we know his angle across, and that sets us up for a sine law. Alright, so let's find y using this triangle in here, which is a 90-degree triangle. After we find y, we'll be set up to use the sine law so we can find x, the height of the house across the street. Alright, so let's set that up. So here I've taken this 90-degree triangle here and redrawn it over there. And I want to find y, and I'm going to use SOHCAHTOA. So the angle of 5 degrees, well, just below it we have him as his adjacent, and it's known, it's 75, and this long side is the hypotenuse. And anytime you need A and H, they're involved in cos. So ka. So the cos of 5 degrees, and we do adjacent over hypotenuse. So 75 over y. Okay, and we're going to need to cross multiply. So let's set that up. Imagine there's a 1 there, and we cross multiply as follows. So y times cos 5, and then 75. You're going to have to divide out cos 5 on both sides. And that cancels. Y is 75 divided by cos 5. Grab your calculators, and you'll get the following. 75.3. And it's meters. Okay, so that's good. We now know this value of y. Now we're going to move to that next step with the sine law, so we can find the height, or the approximate height, x. So the height we're going to find is involved in this triangle here. Okay, so I'm just going to draw a sketch of that over here. Okay, so we're trying to find x. Just drawing it there. We just found side y, and side y is 75.3. and we know that this is 80 degrees. We also know that 10 plus 5 makes for an angle of 15 degrees over here. Okay, so you should be able to see that you can use sine law on this. These two here, he's unknown and he's the known angle. And then you have another pair here that is completely known. And we write out the sine law as follows. So we're trying to find a side. So x over, and so there's x. You put them over the sine of 15 degrees. Okay, and then you grab a corresponding pair that's complete. So we have this here. We have 75.3 over the sine of 80. And then you're able to cross multiply. And you'll be able to set up your answer. Okay, so x equals 75.3 sine 15 degrees over sine of 80. And you can calculate that with one shot in your calculator. Okay, so 75.3 times sine 15 divided by sine 80, and you end up with 19.8, and that would be meters. And actually, that seems fairly reasonable for house height. Okay, now we do acknowledge that that height of x, which takes us up to, midway through the roof, is not quite the height, just the way the problem was explained, the way Tom was looking. But the trigonometry still holds, and we would have a height of 19.8 meters. Part B now, it says find the height of Tom's bedroom window. So go back to your diagram. There's Tom's house, and find the height of Tom's bedroom window. Well, you're going to be able to do the following. You're going to be able to get from where he was basically looking to the ground, so right there. And let's call that height, not Z. Okay, so that height Z from the ground up to where Tom was looking is involved in, well, a few triangles, but the one I'm interested in is this one here. Okay, so I'm going to redraw that triangle. Okay, we're in part B. And if I redraw that triangle, just to sort of see it more clearly, it would look like this. So there's Z. This is the 75. And if I come down here, that's 90, because the road or the grass makes a 90 degrees with the side of the house. And this is 10 degrees, thanks to our angle of depression Z rule from earlier. And right away, you should recognize that you can use SOHCAHTOA. This is a 90-degree triangle. And if we start labeling off this reference angle, okay, cross from that 10 degrees, that's your op. Beside 10 degrees, that's your adjacent. All right. And you're now able to, you should know that that's tan. Tan involves op and adjacent. So if you do the tan of 10 degrees, and tan is a TOA, okay, you're going to get your answer. So let's go for it. Tan of 10 degrees, op is the unknown Z, height of the window, and adjacent is 75. And you'll need to quickly cross multiply into there. Z. Okay, just going to get rid of this. So Z equals 75 times tan 10 degrees. Z equals, let's work that out, 75 times tan 10 is 13.2 meters. All right. So we've solved the question. It's not so straightforward, but we are using our skills from trigonometry that we've seen. It's probably the first time you've seen a larger question like this. So some practice, some patience, some effort pays off. All right. We can summarize. So the neighbor house is 19.8 meters high, and Tom's window. By the way, Tom's window, which is 13.2 meters, did work out to be less than the house height, which we're happy to see. The number they're working out, okay? And it's also proportionally, about 13 of 19.8 makes sense. So the trigonometry holds up. It is a bit of an approximation, and that's how you do one of these questions. All right, for example 2, this is one we're actually going to cover in class. So we'll do this together in class. Make sure you have your note with you, and we'll take this up. All right, in example 3 here, we've got Matt. He's taking his boat, and he wants to get to Jeff's cottage up here. But before he goes, Matt has to go to the gas station, and then he's got to continue on to Jeff's. Now, normally the distance that Matt would take to Jeff's is right from here up to Jeff's, and that's 6 kilometers. Okay, so it says to use the picture and all this description, and you have to find the total distance that Matt took going kind of by the gas route. So Matt went this way to the gas station, and then he continued off to Jeff's that way. So there's 2 unknown distances. We don't know this distance here, x, and we also don't know this distance here, y. So to solve a question like this requires trigonometry. We have a look at this. If we have a look at this triangle, we do have 2 angles given, and we can quickly get the third angle. We know all triangles add to 180. So 180 degrees, take away 18, take away 27. We realize this last angle is 135 degrees. So let's add that in. Okay, from here to here. And now you have to think about your approach. So we have 2 unknowns, 2 sides that are unknown. And, well, this is not a 90-degree triangle. We cannot use Pythagorean theorem. We cannot use SOHCAHTOA. That only leaves us at this point with the sine law. Okay, so sine law is the way to go here. And let's start with side x and see what we can do. So if we want to find side x, okay, so that's our first step. Find x. If we're going to sine law with side x, the way you write it, as we've been doing before, is you have to write x over. Now, which side is he opposite to? Okay, he's opposite to, which angle is he opposite to? He's opposite to angle 18. So x would have to be over sine 18 degrees, which is great, we know that. And then you have to equate that to an angle side that we both know. So we've already said we want to find x with 18. Let's compare this angle with this side, and that's great. We do know those two. We know side of 6, who corresponds with an angle of 135. That's what we want to go with. So we're going to go with 6. Corresponding angle is sine 135 degrees. And you're ready to cross multiply and just calculate this. Okay, so let's do it. When you cross multiply, you only have to send sine 18 degrees up to the numerator, and it's 6 times sine 18 degrees And then on the bottom, the denominator is still sine 135 degrees. And your calculator can give you that answer right away. Okay, so let's do it. 6 times sine 18 divided by sine 135. End up getting 2.6. So that's 2.6. And in this case, it's kilometers. Great, so we have one distance. We also notice it's reasonable. I mean, to get to Jeff's, it was 6 kilometers. Now we're looking at 2.6 kilometers. Next up, we want to find out what side y is. So we're still stuck with sine law. This is not a 90-degree triangle. So let's check if side y will let us use sine law. Now, it won't always be the case. You may have to do a few checks when you try and use sine law. You always do the same check. I want to find y. There he is. So who is opposite him? Which angle? And it's the 27 degrees is opposite him. Okay, they're always opposites whenever you put them in. It's the sine law. So y over sine, we do know the 27 degree angle. Then you need another pair. So you could put the 135 again with the side of 6. That works. And at this point too, you could put 18 degrees with x, because x is known, but you calculated that. So it's not like a guarantee it's right. So I would stick with using the known side of 6 and the angle of 135 degrees. You're pretty confident with that 135. I mean, all triangles add to 180, so it's definitely 135 there. So you want to go with 6. He's known, and his corresponding angle is sine 135 degrees. You want to cross multiply, and we've been doing this a lot, so 6 times sine 27 degrees over sine 135 degrees, and that goes directly in your calculator. Okay, so here we go. 6 times sine 27 divided by sine 135. You get 3 point, well, we could round that to 3.9. And it's kilometers. I like that number. It suits this application. Feeling good about it already for that reason. And now read the question, because it does say in the question, using the picture and description, find the total distance Matt will travel to Jeff's. Well, Matt drove 2.6 kilometers, and then he drove, how much was it again? 3.9 kilometers. So your third and final step would be like the total. You'd add them up, right? It's x plus y. So it's the 2.6 plus 3.9, and then you end up with 6.5 kilometers. So you can answer the question now. Matt drove 6.5 kilometers. So a little bit of a detour, only an extra half kilometer worth of driving. All right, bring those questions to class. These applications require lots of practice. It's good to make errors in the sense that you'll learn from them, and it's good to take a chance and try stuff. So we'll get a good work period in on this and help you out in class. See you soon.